Welcome back to another video. In this one, we're going to talk about how to wire a 3D printed PCB. Wiring a project usually means choosing between two headaches: a messy rat's nest of breadboard jumpers that fall out, or the fumes and permanence of soldering. But what if you could 3D print your way to a clean professional circuit? Today, I'm showing you how to wire a 3D printed PCB, a simple, solderless and reusable alternative to traditional prototyping. To get started, you only need two things: 26 AWG wires and a 3D printer, and of course, the components you want to connect. Once your PCB comes off the printer, the first step is cleaning out any leftover material inside the wire channels. This ensures the wires slide smoothly through the long slots. Next, take a small screwdriver or a similar tool and gently open up the holes. You want just enough space for the microcontroller pins and the wire ends to fit comfortably. Most 26 AWG jumper wires come pre-soldered on both ends, which makes them perfect for this 3D printed PCB. Start by inserting one of the soldered ends into the first hole. Let the soldered tip sit comfortably inside the hole, then press the insulated wire into the channel until it sits flush against the surface. Now, follow the wire path. Guide the wire along the slot, gently pressing it in as you go, until you reach the hole at the other end of the path. This gives you the exact length you need. Once you reach the end, mark and cut the wire just a little longer than the distance between the two holes. That extra bit of length makes it easy to insert the freshly cut end into the second hole. After cutting, twist the exposed strands on the cut end so nothing frays out, then insert that end into the final hole. If you have a drop of solder, tinning the ends makes them even more durable, but for a true no-solder build, a tight twist does the job perfectly. The wire now sits neatly inside the slot, with both ends locked in place. The more you do this, the faster and more natural it becomes. Before mounting any modules, it's important to do a quick manual inspection to make sure your PCB is safe and free from accidental shorts. Start by flipping the PCB over and checking the back. If you see any small pieces of wire sticking out of the holes, trim them flush with the surface. This prevents wires from touching each other and creating a short circuit. Once the wiring is done, you can mount your microcontroller and modules directly into the printed sockets. You might think everything would fall out easily, but as shown in the drop test, the wires and modules stay firmly in place. It's surprisingly robust and doesn't require delicate handling. Next, use a multimeter in continuity mode. Place the probes on two wires that sit next to each other in the PCB. You should hear no beep. That means the wires are not touching internally. Repeat this for all adjacent wires. This simple inspection step ensures your 3D printed PCB is clean, safe, and ready for use, just like shown here. Compare this to a typical prototype board: messy wires everywhere, overlapping circuits, and a constant risk of short circuits. With the 3D printed PCB, everything is clean, organized, and clearly labeled. You always know exactly where each wire goes. And the best part, nothing is soldered. You can reuse the same microcontroller and modules endlessly. No desoldering, no fumes, no burnt fingers, no mess. And because everything is reusable, it naturally becomes a fantastic learning tool. You're not wasting components, and once you print the board, it's just plastic, PLA or PETG, durable and reusable. Beyond being fume-free, this is a great way to use up those end-of-spool filament scraps that aren't enough for a big print, but are perfect for a small, functional PCB. And if you make a mistake, you only lose a few grams of plastic, not an entire prototype board. The microcontroller and sensors are reused endlessly too, with no desoldering and no damage. Just unplug them and move them to the next project. Most modules are interchangeable. The microcontroller stays the same. The board is designed around its exact pin layout, but the sensors you plug into it are completely swappable. Any 3-pin sensor with the signal pin in the middle will fit into any matching 3-pin slot. whether it's a DHT11, a DHT22, or a Hall sensor. And for I2C sensors, the pin order never changes: VCC, ground, SCL, SDA, so modules like the BMP280 or AHT20 all drop into place without rewiring. And when you swap sensors, you simply load the matching code onto the same microcontroller. Same board, same wiring, same microcontroller, different function. Since the channels are exposed using color-coded 26 AWG wires, red for 5 volts, black for G and D, yellow for signal, makes the board act like a visual map. It's much easier to troubleshoot than a green PCB where the traces are hidden. I designed this system because I was tired of waiting 2 to 3 weeks for traditional PCBs to arrive, only to discover a mistake and wait another 2 to 3 weeks for a revision. With a 3D printed PCB, I can fix mistakes instantly, print a new version in minutes, and keep iterating at almost zero cost. This is just the beginning, and I believe this approach can become a powerful tool for anyone learning electronics. No soldering, no fumes, no expensive equipment. Just a 3D printer, some wires, and the freedom to experiment. Thanks for watching, and I hope this inspires you to try 3D printed electronics for yourself.